truth table for NS already we have seen. State table, state diagram. So we have already seen about this. Kmaps for NS1 and NS0. Corner map for next state 1 and next state 0. This is P1 P0. This is now for NS1. Here 1 and here also. So NS1 equal to T bar PSO plus T bar PS1 plus PS1 PS0. This is here. This one for here. This one for here. Here also. Here. And then here. Here. Here, this one, PS1 bar, PS0 bar, this one, bar here, this one, and this one. Here, actually, this one here, this one, this one, this one. So we got NSO next state 0 equal to T PS1 bar plus T bar PS0 bar plus PS1 bar PS0 bar. Truth table and the equations for Y. Truth table and the equations for Y. Truth table. Recall more FSM, so Y will not be a function of T. PS1, present state 1, present state 0, Y1 output, Y0 output. Recall more FSM, finite state machine, so Y will not be a function of T. Y will not be a function of T. By inspection, we got like this. Y1 PS1 present state 1, Y0 Y0 equal to present state 0. logic circuit. Here this is F logic. This is F logic. This is F logic. This is H logic. Register. Simulation. Simulation. Reset. Clock. T. And then the present state. Yes. And reset from approximately 200 nanosecond up to 1 clock 0 1. Here T is 1 microsecond from here 1. After that from 1.6 to 1.870 0. Present state here up to 0 300 nanosecond, and then one output up to 500 nanosecond, then getting two output up to 700 nanosecond, three output getting up to 900 nanosecond. Here all are 0 to 1. Here positive edge only, not negative edge. While clock. Here also while getting 2, so in 1.1 microsecond. Here 1.3 microsecond. Here 1.7 microsecond. Memory devices, flip-flops, D flip-flop, truth table. Q1 follows D flip-flop, D on rising edge of clock. Symbol D input clock positive edge, rising edge, set point preset, output Q equal to Qn plus 1, Q bar. Here reset clear. Here reset equation rising clock Q1 equal to Bn. We got D for data input, CLK for clock input, Qn for register output, Qn. Truth table. Here this is data input. This is data input. That is here. And then clock input from here. Okay. Preset bar here. Okay. Set preset. Reset bar. Okay. Here. for clear, reset for set, reset for clear. Okay, this one. Q1 plus 1. Q1 is reset output. Here output. This is for Q1 plus 1. So we got Q1 plus 1 dn here. Qn equal to Qn then equal to dn. Okay. T flip flop toggle change state on every tick of clock. Change state on every tick of clock. Symbol T flip flop data here, then clock same like D flip flop, and then preset for set. Okay, preset bar, and the reset bar for clear. Okay, Q for output Qn plus 1, here Q bar output. Okay, change state on every tick of clock. T for input, clock for from here, clock reset from here. Okay. And then reset for set, reset for clear. So this one here, this one, and then Qn plus 1, Qn plus 1 output. Okay, Qn plus 1. This is the truth table. Equation while rising clock, Qn plus 1 equal to T bar. Okay, Q1 plus T Qn bar. Here D data, clock also data, 1 0 output 0, D 0 1 1, here only output 1, and then D 0 1 1 Qn, D 1 1 1 Qn, 0 rising edge, tick the clock, 1 1 Qn, and then we are getting Q bar n, 1 rising edge 1 1. So Qn plus 1 equal to, here only getting T 1. So TQn here. So T bar Qn plus T Qn bar. And then S or F flip flop, set and reset flip flop. S for set, R for reset. So set equal to implies Qn equal to 1. Reset Q1 implies 0. Symbol preset. Here SR flip flop